Good afternoon, everybody. Myself Akshay Jalova, and I am here to deliver a lecture on microwave and radar engineering. And under this subject, today we will be covering the topic introduction to microwaves. Broadly, I will discuss what the microwaves are and what are the various basic aspects of microwaves. So, as per introduction goes, by definition, microwaves are the electromagnetic waves having wavelengths of the order of millimeters to a fraction of meter, or in other words it can also be defined as the waves in the frequency range of 1 gigahertz to 1000 gigahertz. So, these frequency waves which lie within this range means from 1 gigahertz to 1000 gigahertz, they may be termed as microwaves. Here is the radar frequency band designation. In this the microwaves are classified in different bands, and as per band designation we have the nomenclature given to a particular range of frequency, and that frequency is identified with that particular band. For example, high frequency HF, this extends from 3 megahertz to 30 megahertz. VHF, very high frequency, this is from 30 to 300 megahertz, and if we are talking specifically about radar, then it is from 138 to 144 and 216 to 2 to 5 megahertz. So, radar I will not be discussing today, because this is the application of microwaves. Today we are concerned only with the microwaves itself. So, we will be going with the first two columns. Then comes UHF, it starts from 300 megahertz and it goes up to 1000 megahertz. Then comes L band, it is from 1 to 2 gigahertz. Then S band, it is from 2 to 4 gigahertz. Then C band, it starts from 4 gigahertz and it is up to 8 gigahertz. Then X band, it is from 8 to 12 gigahertz. Then Ku band, it starts from 12 gigahertz and it is extended up to 18 gigahertz. Then K band, it is from 18 gigahertz to 27 gigahertz, and then Ka band, it starts from 27 gigahertz and it is extended up to 40 gigahertz. So, these are the basic bands. Apart from this, we have another bands also which also lie in the microwave frequencies. Those bands are say mm band, which lies in millimeter wavelength, and then we have sub band. So, these bands are these two bands, band and sub band, means sub millimeter band. These are bands which have frequency above 40 gigahertz. So, any frequency range, if you have to refer, will refer to a particular band. For example, if we want to refer to a frequency range of 4 to 8 gigahertz, then we will say that this is the C band in which a particular operator or a particular device is being operated. Now, I will discuss the applications, the area where microwaves are used or microwaves find their application. First is navigational aid on ground and sea. So, any aid given to navigation means in naval journey we use microwave frequency for that, means for sending the signals, for finding the direction in which a particular ship is moving, or what is the distance of a ship from the shore, or what is the distance between the two ships which are going away or coming towards each other. So, these communications are done on a frequency range which lies in the microwave frequencies. Second is radar altimeter. This is very important application of microwaves and particularly of radar. Altimeter, altimeter means height measurement. So, this is very important in aircraft control system. Altimeter tells a particular pilot or an operator to know that what is the height of the aircraft at any instant. So, during its takeoff and during the landing of any aircraft, the altimeter, it is the altimeter which is very important device with which the pilot and the ground control system knows at every instant that the plane is at what height, and depending upon that the pilot controls and the ground traffic control gives the signals to the pilot to land and to make adjustment as per the distance of the aircraft from the ground, means height. Next application is radar blind lander, is aircraft landing during the poor visibility. So, as we discussed altimeter, we use radar communication while the planes are landing. Similarly, in the foggy weather, when there is no visibility or visibility is very poor, then the blind lander system, which is also another application of altimeter, is used for aircraft landing system. So, this is another application of microwaves. Airborne radar for satellite surveillance. The satellites, as we know, the satellites move in the space. So, for satellite surveillance we use airborne radars. Next is space applications like planetary observation. So, all the scientists which keep on observing the motion of planets and how the planets move, what is the relation between the movement of two adjacent planets, or what is the relative velocity of various planets with respect to each other and with respect to the position of the scientist also, that is determined by using the radar or the microwave frequencies which is used in those radars. Next application is police radar. This is used for law enforcement and highway safety. All of you might have heard about the radar surveillance system which is being used by the traffic police. So, in this we use continuous wave radar, which is one of the application of radars. So, by using that radar we can know the velocity of a particular vehicle with which it is moving on the road, and if that velocity is greater than the permitted velocity, then they can be picked for the challans, or they can be controlled by the traffic police. They come to know about that this particular vehicle is moving more than the with the speed which is more than the prescribed limit for a particular highway or particular road. So, police use these radars for surveillance. So, all the vehicles moving on the traffic nowadays in advanced cities, they are kept under radar observation or radar surveillance to check the over velocity or over speed of the vehicles. So, this is used for enforcement of law. Next is radar for determining speed of moving targets, as we discussed recently, as when radars are used to find out the velocity of moving vehicles on the road. Similarly, the radars can also be used to find out the velocity or speed of the moving targets which may or may not be on the road, may be on the may be in the space or somewhere else. With the what velocity a particular object is moving, that can be find out by using the radar, and for that particular application the radar used is continuous wave radar. Next is remote sensing, means for weather monitoring. Nowadays the scientists which monitor the weather system or which use their station for weather forecast, they also use radar for sensing the particular disturbances, as we normally hear about the western disturbances or a disturbance in a particular region which may affect the weather conditions in the neighboring areas. So, that is observed and determined with the help of radars, and the radar, as all we know, are devices which operate on microwave frequencies. So, microwaves are applied in that field also. Next is air traffic control and aircraft safety. As radars can be used for controlling the traffic on highway, similarly the radars can also be used for controlling the traffic on the in the air also. So, what is the velocity of a particular plane, in which direction a particular plane is moving, and what is the safe distance it should keep from the other neighboring plane, or from other objects which are present in the air. So, that can be controlled with the help of these devices which consequently operate on frequency which come under the microwave frequency range. So, in this way microwaves find their application in air traffic control and air safety also. Next is ship safety, as the very first application was in navigational aids. So, navigational means the movement of ships in water or sea. So, ships when they move in water, they use microwave frequencies in their operation of radars which keep them at a safe distance from any object which is present in their way. So, in this way this is used for ship safety also. Next application is non contact method of speed and distance in industry. So, there are certain procedures in the industry, and in the speed also, means something which is moving with high velocity, where it is not possible to make a human contact. So, where a human contact cannot be made, and we want to observe the situation, we want to observe the velocity, we want to observe the direction of a particular movement, or any other movement in that particular area, and the restriction is that human contact is not permissible. So, that can be controlled and that can be done with the help of microwave frequencies, which consequently are used with the help of radars. Another area of application of microwaves is military application. In military applications, we use microwave frequencies for number 1, detection and ranging of enemy targets even at night. So, as radars are electromagnetic waves, it has nothing to do with the visibility. So, whenever during the night, or in the region where the human beings are not allowed to go, or are not safe for human being to go somewhere, we use for detection of the enemy and for the targets which may be present in the neighboring area, and that is done with the help of radars which operate on microwave frequencies. So, in this way microwaves find their application in militaries also. Next is aiming guns at aircraft and ships. As we have discussed, ships and aircrafts they move, and their movement and direction can be detected with the help of radars which operate on microwave frequencies. So, they can be aimed once you know the direction of motion of a particular ship or plane, and you know the speed with which it is moving in that particular direction. So, it can be targeted if it is enemy ship or aircraft. Next is bombing the ships, aircrafts or cities even during night. So, this is another application of microwaves. If the military has to bombard a particular city or ship or aircraft, then they can detect that target by using the radar which operate on microwave frequency. Next, early warning regarding approaching aircrafts or ships. As ships and aircraft approach a particular area where the military is positioned or stationed. So, by using the radar, surveillance radars, we can detect that a particular aircraft or ship is coming towards that location, and the precautionary measures can be taken. Next is directing guided missiles. Nowadays, missiles are being guided by the radars, or radars operate on microwave frequency. So, all the guided missiles which are controlled from somewhere else, and they land at a particular location, and during their journey they can be guided, their path can be altered. So, this is another application of microwaves. Next is searching for submarines, land masses and buoys. Any submarines or land masses or buoys, if it is present in some area where the movement has to take place. So, that can be detected with the help of a radar which operates on microwave frequencies. So, these were the areas or particularly areas of application of radar in the field of defense or military. Next, advantages of microwaves. So, why we prefer microwaves? Because we prefer microwaves or we operate at such a high frequency because of some advantages which these waves have over the normal waves or the waves with the lesser frequencies. First is large bandwidth. As we know that microwaves are the waves which operate in gigahertz. So, if we are operating in gigahertz, then it is possible to have a large bandwidth, because in 1 gigahertz you have so many channels which can be applied for say for television communication, or if it is for radio communication or for some other purpose. So, it provides a large bandwidth because its frequency range is in gigahertz. So, large bandwidth means we can accommodate more and more channels, means its utility is much better, better than any other range of frequency. So, that is why this is preferred for bandwidth advantage. Second is better directivity. As we know, as the frequency increases, the directivity increases or the directional gain increases, and microwaves being the frequencies of gigahertz higher than any other frequency which is being used nowadays. So, because it is the highest frequency possible, so it has got the highest directivity also. So, this has got better directivity than any other range of frequency. Next is lower power requirement. So, as we increase the frequency, the power requirements decreases. So, for having the same result, so the power dissipated is very less as compared to the other range of frequencies or set of frequencies, say megahertz or gigahertz, for which megahertz or kilohertz, on which we operate for a particular application. So, for the same application, if we rely on microwave frequencies, then the power requirement is much less as compared to that. And next application is minimum fading effect. Fading effect is something that the strength of signal is reduced or the signal gets attenuated during its journey from the source to destination. So, it fades down, its strength is reduced. So, that effect is very less in microwave frequencies, because at higher frequencies fading effect is very less. So, for this reason also we prefer microwave frequency over the conventional frequency ranges. So, microwave frequencies have got these basic 4 advantages apart from other advantages. Due to this reason, we prefer microwave frequencies, and nowadays it is become very popular in every field of life. Now, we will discuss some radar systems in brief. First of all, it is a monostatic radar, the very basic radar, pulse radar. Here we have a transmitter and a receiver, and here we have a duplexer. So, transmitter is connected to duplexer and receiver is also connected to duplexer, and duplexer is consequently connected to the antenna. So, what is the duplexer? Duplexer is a device which operates in transit and anti-transit mode. Means transit and anti-transit means at one time it connects output to one of the input. Means when we are transmitting the signal, the transmitter is connected to the antenna through duplexer. So, when we transmit the signal, it is connected and receiver is disconnected. So, it is transmitting through duplexer and duplexer is connecting transmitter to the antenna and a signal is transmitted. So, suppose we want to transmit a pulse, we will send the pulse and that pulse will be transmitted through duplexer by using this antenna. So, this will transmit the pulse and here this arrow shows that pulse will move towards the target. This is the target or the object. When it strikes with the object, it gets deflected and after getting deflected, it comes back to the antenna. Now, the duplexer is connected in second mode. Second mode means now it disconnects the transmitter and connects the receiver to the antenna. Now, when this reflected signal comes back to the antenna, it is received by the receiver, because now receiver is connected to the antenna and transmitter is not connected. When this signal is received, then it is sent to the indicator. Now, indicator has got two inputs. One is the input which it gets from the transmitter and another is the input which it gets from the receiver. Now, from transmitter which input it will be getting? When the signal is transmitted, a reference pulse is given to indicator also, which triggers the clock on the indicator. It means that indicator or the display section, it knows that at this particular instant the signal has been transmitted. Now, when signal is received by the receiver, then it is given to the indicator also. When it goes to the indicator, it means now indicator has got two pulses. One pulse when the signal was transmitted, another pulse is when signal was received. So, the timer circuit which is in the indicator, it stops when it gets the signal from receiver. So, in this way we know the time gap which is consumed by the signal to travel from transmitter to the object, means transmitter or antenna to the object and from object to the antenna. So, the time which displays on the clock of the indicator is the time taken by the microwave frequency to travel or the signal to travel from antenna to object and object to antenna, means the time taken is time taken for the signal to travel from antenna to object is half of the total time which is displayed on the indicator. Now, we know the velocity of light and electromagnetic signals travel with the velocity of light. So, we know the velocity, we know the time taken by the signal, we know the velocity of the signal. So, we can calculate the distance travelled by the signal, because the total time taken is for the distance travelled twice. So, whatever the distance comes, half of that is the distance between the antenna and the object. So, this is the simplest application of any radar, where the signal is transmitted. This is how the radar works, very simple radar. Signal is transmitted, it strikes with the object, returns back. Here we have transmitter and receiver connected through a duplexer, and when we send the reference signal from transmitter and received signal from the receiver to the indicator, it gives us the time. We know the time, we know the velocity, we can calculate the distance, because velocity is distance upon time. So, in this way we know what is the distance of object from the antenna. Here I have explained how it works. The distance of the target can be calculated from the total time t taken by the pulse to travel to the target and return to its original initial position. Assuming c to be the velocity of light in free space, the distance traversed by the pulse is c t meters. Now, this is 2 times the target distance, because it is the total time taken by the signal when it is transmitted and when it was detected. So, it has moved from transmitter to object and object to transmitter. So, hence the distance to the target is r, which is range. R depicts the range, c is velocity of light, and t is the total time taken. We divide it by 2 and we get the range in meters. Now, requirements of any radar system, what are the requirements? Automatically operating duplexer, as I have explained what the duplexer is, how does it work. Transmitter should remain silent during the echo period, it should not work when the signal is coming back. Receiver should be highly sensitive to echo signals and should be highly immune to noise, means the receiver should be capable of rejecting any noise if it is present, means it should be immune to the noise, and it should be highly sensitive to the echo signal. Whatever the echo signal, however less the echo signal may be, the receiver should be capable of detecting that, and once it detects that signal, it should be able to display it on the indicator or display board. So, this is the very basic property of the receiver, which is the prerequisite. If it is capable of rejecting the noise and it is capable of receiving the echo signal, it may be a weak echo signal, then it is a good receiver. Antenna should be highly directive and it should have a large gain, means the antenna should be capable of telling the direction of the should be capable of controlling the direction of the movement of the beam, means if it is more directive, it will be having more range. Pulse repetition frequency PRF should be high compared to the scanning frequency. What the pulse repetition frequency is? This is very important term, pulse PRF. It is the frequency at which the successive pulses are being transmitted, means pulse repetition frequency. What is the frequency of repetition of pulses, means at what frequency a particular pulse will be transmitted. So, that determines the PRF. Next, duty cycle, PRF is equal duty cycle over pulse width. P average is PT into x, duty cycle is PT x, pulse width is x PRF. So, any term it can, all these are interrelated, any term can be derived from any one of these. Now, classification of radars. Broadly, radars are classified in the 2 categories. We will discuss them one by one. One is continuous wave radar, it is also called CW radar in short, or it is also termed as Doppler radar, because it works on the Doppler effect. Continuous wave radars utilize continuous wave forms which may be considered to be a pure sine wave of the form cos 2 pi f naught t. Spectra of the radar echo from stationary targets and clutter will be concentrated at the center frequency f naught, for the echoes from moving targets will be shifted by the Doppler frequency. Thus, by measuring this frequency difference, CW radars can very accurately extract target relative velocity. Because of the continuous nature of CW emission, range measurement is not possible without some modifications to the radar operations and waveforms. So, this is CW radar, and basically it is the radar which operates on Doppler effect, which states that as I have just read it out. It states that what the Doppler effect is, that there will be a shift in the received frequency, or in other words we can say the received frequency will not be same as the transmitted frequency if there is a relative velocity between the receiver and the object or destination. If there is a relative velocity between the transmitter and receiver, then the received frequency